All right, guys, we are at Gibson Garage. I'm here with Kara. Kara, how are you?
Hi, I'm good. How are you?
Good. Good to see you.
Good to see you too.
This place is amazing. It's funny. I've heard this. I heard the Gibson Garage described as a big garage with a lot of small garages inside of it.
That's right.
Does that seem to resonate at all?
Yes, absolutely. Because we have a lot of brands. So, we have Gibson, Epiphone, Kramer, and then Pro Audio out there. So there's a lot of representation here in the garage. And it's good to go to each nook and see what's happening with each brand.
How did you find yourself at Gibson?
I was actually working for an escape game company here in Nashville.
Oh, wow. That's so
Yeah,
cool.
it was very fun. I learned a lot, but that kind of honed my skills with woods and plastics specifically. And when I was looking around for new opportunities, Gibson really valued my skills and past experience with working with woods. So
Makes sense.
there's a lot of differences between wood and some of the standard materials that engineers work with today. So wood is ever changing, and the materials we work with are not just one species. It tends to range from mahogany, walnut, maple even.
Yeah, different types of wood.
Yes, and every single assembly has different kinds of wood and other materials. And those materials like to stretch and deform a lot of the times. So what we do is we try to give greater tolerances and really respect the woods that we work with. And we also tend to have higher specifications for the woods that we import into the factories. So for example, the industry standard for a lot of wood used today is usually about 12% moisture content. Gibson actually uses 8% moisture content with pretty much everything that we make.
Okay.
That also comes down to reducing wormholes and organic sort of signs of destruction or tearing or anything, shearing in the wood. We really want to eliminate that as much as possible while also staying green as much as possible. So
Yeah, I like one thing you said earlier about, you said respecting the wood. Very, very interesting approach to that, and I think it shows how you see your designs. It's yeah, I appreciate that.
absolutely, it's a flexible product, and at the end of the day, it has a mind of its own.
Yeah.
So unless you're willing to
Yeah.
work with it, it will go against you at times. And that is one of the biggest challenges. We're trying to machine a product that moves. It's and
Wow.
so, but it's definitely part of the process. It's one of the challenges that makes working in this industry so fascinating and fun. Personally, I've taken it upon myself to study more of the mechanical properties of the different species that we work with and really try and understand the hardness rating and different properties across the grain, and things along those lines. It's complicated.
Yeah,
It's complicated.
that is insanely interesting. And again, not something that, viewers looking at guitars, they necessarily would think about, but you have to. And then
Absolutely.
everyone else benefits from it. That's so cool. That's so
Yeah.
cool.
So my job is to, as best as possible, use the tolerancing that I can with wood in a way that tells our machinists what needs to happen while respecting the complexity of an organic material. So all of the materials, a large portion of the material of a guitar is organic, and that actually adds a lot of complexity to our designs.
Yeah, what do you find most interesting about working on guitars?
I love the history behind the guitars we work on. Usually,
So sounds like that's one of your favorite parts too. I mean,
The
that's what I find
history.
myself like really zoning in on.
absolutely. Every time I work on a specific model, I dive deep into the history behind why it was made a certain way or how it was made.
Why?
Yeah, the why, the how, who made it, who were the engineers originally involved. For me to properly design what we work on and the prototypes that we design, I have to know how it's made. I have to know what's happening at the 6th, 7th, 8th stage of the process. That's extremely important to me. We do not design products in a vacuum. So for me particularly, my design process, I try to keep as well informed by the process that happens. The hardest journey to take is navigating the threshold of the original engineering intention behind some of our designs, and will this still work with our current production outline and our current production limitations.
What is your reverse engineering process like?
So we use a mesh to CAD workflow,
Okay.
and we use a 3D scanner. It's called the Handy Scan by Creaform, and the program it comes with is called VIX Elements or VIX Model, and it provides a lot of robust tools for working with surfaces that need to come into Solidworks, and it actually has a built-in transfer to Solidworks tool. A lot of the ways
Very cool.
Yeah. So a lot of the ways we use it is just to take splines, cross sections, and clean up the mesh that we're working with. Usually that's some artist neck that we've scanned, and probably a body involved, and some hardware as well, some of the pick guards and stuff like that. And then we take cross sections and transfer that to CAD and use all of that information as much as we can to properly replicate the product. And a lot of times we have to try and retrofit our current production process onto those scans as well.
Yeah.
To make a combined CAD model that fits everything we want to do.
Wow.
Yeah,
that is
a lot.
Yeah, I know that is but that is a super cool usage of modern technology. And again, like in the interest of this huge knowledge share with these thousands of people, like that is good to hear that you guys are using that workflow. That is probably repeatable with a lot of different types of products, right? With 3D scanning.
Absolutely. We have to rely on that program as much as possible, because otherwise it would just be tracing lines and arcs all over the place, and that's a huge amount of time for the kind of work we're doing here.
Yeah, and it also sounds like, we all love details in technical fields, but maybe not to that minute level where you're just tracing lines and splines.
If
and
they'd
arcs.
let me, I would focus on.
I know exactly what you mean. It's like I could just zone in on it for hours. Yeah, exactly. Well, it's interesting. So, again, 3D Experience World's coming up. When I think about 3D Experience World, obviously I'm thinking a lot about SolidWorks, right? There's tons of SolidWorks content there. And of course, I'm surrounded by these guitars. Going from CAD to complete a guitar, you just talked about how there's so many variations in the physical making that maybe you're not, even if you had the perfect CAD model, that maybe could not get accounted for. What are some interesting points in that process, going from CAD to creation, that always kind of stick out to you?
To the best of our abilities, the design that my coworker and I work on try to take into account how something is going to come off of a machine. For example, our necks. We usually take the fingerboard dimensions, and around the 12th to 16th fret, usually right in this area, we'll need to give it some fluff, about 30 thousandths on either side.
Okay.
So that when it actually gets made, there's some tolerance for hand sander to come in and sand away some of the material to cause it to be flush to the body. Another example of ways that we have to retain some of this. So during the process, this neck portion gets fitted with a metal rod. It's called a truss rod through the entire neck. And that is called jointing. So when the neck is jointed, they want to produce it in a way that there's slight tension on it, so that if a consumer takes off this cover, they can adjust this rod. What that does is it causes the fingerboard to bow either in a convex or a concave way. And some of our guitars are made with single action truss rods. Some of them are made with double action truss rods. And for the most part, what we do here at Gibson is we tension the rods in a way that it's playable as soon as you pick it up. And that process is incredibly unique and complex. But designing the necks in a way to honor a ton of hand operations. This neck goes through 3 or 4 different operations. It looks completely different from what it's supposed to look like when it comes off the machine. So a lot of times when we reverse engineer products, we have to take into consideration about 50 to 70 thousandths of material that gets shaved off.
Wow.
And then the position of our brake line for the nut gets adjusted a lot during that entire process. So all of this is usually very, very difficult to nail down as part of the reverse engineering process. And another fun thing about guitars, not a lot of people know this, the necks are not symmetrical. We actually have
Yeah.
asymmetrical necks on a lot of our models. Some of them are symmetrical, and some of our necks have more of a rounded profile. Some of them have more of a slim taper profile. And each and every single one of those profiles is unique. And now when we are working with a 3D scan of an artist model, we have to use splines or other sort of asymmetrical geometry to properly replicate those guitars. And it's not a one-size-fits-all ever. It's
Wow.
very tedious and very, very fun.
Yeah,
yeah.
it sounds like it. I can tell like you were super interested in this, and
Yeah.
there's so much art and engineering, and it's like the complete merging of the two. And you're right. I don't think a lot of people do know that. This will be live. Let us know in the chat if you did know that a lot of the necks can be asymmetrical.
Yeah.
I surely had no idea before I got here, and you told me that. So
Yeah,
very cool.
That is literally, that's a lot of the detail though. And that was all neck oriented basically.
Yeah, I'm sure
There's a whole lot more when you start getting into the headstock and the body of different models. I'm gonna go put this back, okay?
Yeah, right.
Before I drop it.
I think people so often like they see a beautiful guitar, but they don't know how it was made or like the challenges and the things that you have to consider. That's design and engineering in a nutshell.
Yes.
And then you come out and there's just this beautiful guitar and there's this beautiful Gibson Garage, and somehow it gets made.
Somehow. It's shocking sometimes.
Yeah. But no, I'm glad to see you're going to be at 3D Experience World, right?
Absolutely.
Right. So tell us, like, what are you most excited about for the conference?
I'm hoping to see some tools of the trade, tips and tricks, especially regarding surfacing. My coworker and I work a lot with surfaces.
Yep.
We work a lot with splines, and I think we would really benefit from looking at better surfacing practices in general and finishing as well. I'd like to really look at our use of graphics and replicating the mother of pearl appearance on our inlays and the abalone appearance on our inlays as well. We already really do that in some of our CAD products, but sometimes when you get to more complex assemblies, sometimes those appearances tend to be weaker and they don't show up as much. And just a few different things like that I think we could really benefit from. I also would be fascinated if there was a presenter on, let's see, sort of really complex assemblies. Recently, for my team, I designed a guitar in Solidworks that actually had a customizable bridge on the guitar, which allowed me to adjust the string height and tensioning. But it was really, really hard, and I had to do it in a roundabout way. So I'd be interested to see if there'd be any speakers or presentations on working with ridiculously intricate assemblies and different ranges of motion.
That's so interesting. And I love the in-person effect, right? Because you can go to a session on complex, assemblies, or you can go to a session on surfacing, and it's, hopefully, and you almost always do, like you get useful content that you can take back to work, but then it's also like there's people in the audience that might have the answer, right? And it's like just meeting those people that are working on similar things. That's the magic, I think, that can't be replaced entirely with a virtual conference. It's like just being in that room and being in that network. I think that is That is so cool. But that is for 3D Experience World. I'm going to take full advantage of being here. I've already taken so much advantage just by talking to you guys. Kara, thank you so much. This has been great.
Thank you, Sean.
I guess first off, what do you do here at Gibson?
I'm a CAD designer. I have a background in mechanical engineering, so I work in the product development team doing design work for Custom Shop and for the USA and Epiphone and all of our different brands.
Nice. Yeah, I think a lot of people watching at home or, whether they're at the conference, wherever they're from, being a CAD designer, like if you just put that on your resume, like I'm a CAD designer at Gibson, probably like super jealous. I know I am, just like even talking to you. I'm like, wow, it must be so cool to be a CAD designer at Gibson. And the stuff that you're talking about, it's very, I'm sure, we're at 3D Experience World. It's a big design, engineering, manufacturing conference. People from all different industries. Like a lot of the stuff that you're talking about, it's like, these are sort of relatable concepts, right? Like you're talking about 3D scanning, converting 2D to 3D, like modernizing your processes in some ways for at least for CAD, right?
Yeah.
Like we're talking about CAD. But you just get to work with guitars. So like, that's the cool part,
Yeah.
Everyone can find like, and that's the beauty of it. It's like everyone can find that like that certain perspective in terms of what they do and what it means to them. And whether you're making guitars or something else, right? But guitars, I'd imagine it's a little bit easier. What sort of pride does it give you to be working on Gibson guitars?
Yeah, Gibson's such a huge name in the industry, and I mean, when I moved down here, I would have never thought in a million years that I would be working at Gibson, and I've been a fan of Gibson for decades, and it's like, I've been working here for 2 years, and I mean, it's still kind of hard to think that I'm working here.
Yeah, like one curiosity that I have for you, and I'm sure everyone's wondering, like, okay, so you've been working at Gibson for the past 2 years. Like, what would have been some other stops in your career? Because we have a lot of students. We have people that maybe are like, oh, I would love to do that someday.
Yeah.
Where is your path kind of led you, and how did you wind up at Gibson?
I started off in the tire industry, kind of doing machine design,
Mm-hmm.
and through the pandemic and kind of getting laid off, this was my first opportunity coming out of that, and it's just been an awesome opportunity. And really, I think I can find myself here growing throughout the company because there's so much to learn about the manufacturing process and design process of all the different types of guitars, and it's just a really cool experience going from like a metal world to a wood world. It's
Yeah,
completely different.
you're saying to me that the manufacturing side is actually something that you're really interested in. What's one thing, you can give more than one, it's fine, but like one thing that you think people would be really either interested or surprised to know about manufacturing in this industry, like manufacturing guitars?
Yeah.
Like what were you surprised by, or when you tell people, like, what are they surprised by?
Yeah, I would think that a lot of it would be more machine work than hand work, but after being here, there's a ton of hand work in the manufacturing process, and that's how a lot of the time every guitar is just a little bit different from hand sanding, and the skill that some of the workers have just with putting everything together is really like awe-striking and just awesome to see. Definitely surprised me with just how much differentiation there's between like steel work of my background that I've seen is just a lot of precise design and manufacturing, and this is a little bit more free flow.
Mm-hmm.
So, a lot more forgiveness when you can sand the problems away.
Sand the problems away. Yeah, and there's so many ways to do surface modeling now, right? There's the SolidWorks 3D CAD approach with making different faces, forming a solid body. There's X-shape with subdivision, kind of free-form modeling.
Yeah.
And there will be, as always, at 3D Experience World, no shortage of SolidWorks classes. So, yeah, I guess if anyone sees you, say hi. You're now going to be 3D Experience World famous. I'm sure someone's going to see this and be like, oh yeah, it's Alex. Gotta ask him about Gibson. But no, and of course, if you walk by the live booth, we'll have like a big booth there. You know, walk by, say hi. Maybe we
Alright.
can have you on again.
That'll be awesome.
Cool. All right, Alex.
I
Thanks
appreciate
a lot,
it.
man. Appreciate it.
Thank you.